So this is Spark exercise. The data used in this exercise is yellow taxi dataset of New York. This is the schema. There are pretty much files 2.8 gigabytes, 27 files for almost 5 years. So the exercise, various tasks of this exercise will be run on this data. Okay, first one. Uh, okay, the first area are simple select. This is select of 3 columns showing the result. Okay, the next exercise is about showing selecting columns which have word amount in the column name. There are 4 columns in it, nothing. As you can see, I used asterisk select before the list. This can be done. Also, the list itself can be placed here. Okay, next exercise is selecting columns with aliases. You simply get call around column name and dot alias after it. Now it selects them. Okay, select specific column by name. Simple exercise. Selecting 3 columns by name. You see, you can do this, or you can actually place them in a list. You see, you can place list here. That's so if you just use select column list, this is equivalent to this syntax. But if you place asterisk column, asterisk inside list, this is equivalent to this syntax, meaning you pass 3 params, or you can pass a 1 param which is list. The result is equivalent. Okay, select all columns of specific type. So you use list comprehension with if instance of a certain type. So these are all double types. Okay, selecting all columns in space except specific column. Again, same thing. We create list, we select based on this list. Okay, selecting columns in a different order, nothing special. Selecting 2 columns with alias, nothing special. Again, selecting columns if you mounted them. Selecting last 5 columns, you simply take same Spark frame and taking first 5 columns, or you can do it this way, So you can do it via select, or you can do it via brackets. The result is the same. This is selecting last 5 columns, again via select or via brackets. The result is the same. Okay, next is about adding columns. So renaming to vendor ID. Ben, and we have the column renamed. So adding multiple columns with 2 with column rename statements. Okay, we renamed and pickup time. Yes, it was renamed. Okay, having some columns renamed, some not, and the result is the same. Okay, bringing all columns to lowercase. So you just you create this construct call C alias C lower, and you make it into a list via list comprehension, so all columns are lowercase. Uh, Selecting uh, columns with a prefix, so all columns prefixed. We have taken call, alias, and some string pattern that modifies column name. Okay, uh, re renaming on all columns from underscores, which is called snake notation. This is snake notation. This is camel notation. So this is a function that does such renaming on any on any kind of identifier, and so we do call alias snake to camel from call, make it into a list, and making select. And here we have columns now in a camel notation. Okay, conditional renaming certain renaming amount columns to prefix amount. So if it contains amount, it is aliased with empty prefix. Otherwise, it's simply called C. And here we go. These are normal columns, and yes, this is amount prefix. Extra renaming column. So if the column existed, is renamed. Again, simple if uh, rename using dictionary. So call alias rename dict. So we pass names through the dict, but only for those which exist in a dict. For others, we simply leave them as calls. Okay, using regular expressions. In this exercise, we cleaning column names. So the fake columns were created with spaces or special characters, and then the names have been passed through this clean identifier, and as we can see, uh, this should, yes, improvement surcharge was stripped of illegal characters, and trap and drop of daytime also was stripped of spaces. So okay, this was column name cleaning. Okay, next thing is add a column with a constant value. So column with lit was added. We have data source with the same value. Okay, create a new column equal, which is a sum of columns. So uh, we create with column name, and two calls are summed. This is some kind of a trick that works on this column class, which creates sum. Uh, and this is fair plus. This is the second fair plus. It was also put through round. So as you can see, this value has been rounded to 4 digits, but digit is only one. And then we selected only 4 columns from this data frame, and we see using only sublist of 4 columns. Actually, lock and iLock are not working on a Spark frame. This is not the same as data frame. Okay, create average cost per mile. I actually created it, but I added divide by zero check. And so, as you can see, this is a normal division. This is case where division by zero was encountered. So and I have converted division by zero to zero result, not to none. But it can be converted to none as well. Okay. Add column name, which is enum of yes or no. So if it is greater than 10, then yes, otherwise no as string. Okay, and here we have two checks. So these are long trip yes, and these are long trips no. So this is where and two columns. Okay, this is a conversion to three enums. And when less, when less the next step, and otherwise long. And here we have short columns, medium columns, and long columns. Okay, next one. Add columns with two expressions. And here I played some tricks with nulls actually. But nulls didn't exist here. Okay, so I used a coalesce and then null if I am throwing it to zero. Okay, this might look complex and we have no data which is null, but we will see below the test which checks for null. So again, if we divide by zero, we got zero result. What is empty tax? Okay, so this is stall plus MTA, which is summation of these two. Okay, that's okay. Okay, printing date in a certain format is done by date format function, which accepts column and format pattern. Okay, adding true or false column based on the expression. Actually, with column and boolean expression right away. So column passenger count equals 0. And not even literal 0 was required. And actually, and it works in both cases. Okay, else false. This is another way of doing it using expression. This is the same thing. Passenger count equals 0, but it's done via expression function. And again, we have one false, true, 0. Okay, similar task, create Boolean expression using expression syntax. So here, but here I used coalesce function. And coalesce function handles zeros. See, it has given false even though the value was null. Null values did exist. Okay, next task is to create concatenation of strings, and I have done concat, which uses column, literal def, and another column, and it has concat all these values. These columns actually numbers, ints. They're ints, and they have been converted via concat. But here is extended dummy example. I have created combination of null, not null, and I have created three columns. First is a straightforward concat. Second is concat uh, with uh, with coalesce, which protects against nulls. And here I tried another example to cast int to string before concat. So what we have as a result? In the first case, where simple concat, any none brings the result to none, to null. So if left null, right null, both nulls, the result is null. Okay, this expression is null safe. So it's because of a alias. But the problem was you have to, I had to convert the column to string in order for alias to work between two strings, because alias didn't work between number and string. So I have to cast and then make it as a alias. Make, make it into empty string. So this second expression always produces a result. It's null safe. This thing, though the expression was cast to string, still is not null safe. Any null brings it to null. Okay. The next part of the exercise is about drops. So this is simple drop of a column. This is drop of several columns. This is drop of a list of columns. As you can see, asterisk list is equivalent to this notation. This means that we are passing two parameters. And this doesn't mean that we pass one parameter as a list. Okay, dropping column if exists. Okay, if exists and we have dropped it. Okay, and drop all columns except this one. So we have columns to keep. Then we create columns to drop, which are not columns to keep, and then we drop. We put it asterisk. What actually will it work if we no it doesn't work on drop. So on drop we cannot pass list. On drop we should pass individual parameters. So if we have list, we have to put asterisk list, and all the params will be used. All the list elements will be made into individual params. Okay, this was the task was to drop all columns containing the location keyword. Again, you see when we created list, we use asterisk list. So this is multiple parameters function call. Okay, drop all columns with specific data types. So we collect all the columns and their types. So this is the collection of types which is passed by enum column type, and if t is in a certain type, we collect columns. So and then we drop, and we have only non-long and double types. So we have string, date. These are probably small integers that they were not dropped. Or no, no, they are not floats or doubles. Otherwise, they would have been dropped. Okay, drop all string columns if the types are string. Okay, drop all columns which end with underscore amount. So again, we collect the list and we drop all these columns. Okay, this were simple Spark exercise on the subject of creating columns, dropping columns, and selecting columns. And these were run on taxi dataset.